This is exercise 13.3, standard ditch hydraulic analysis. In this exercise, we will analyze input flows from a ditch from the approximate high point to the approximate low point. For this exercise, it is assumed that the user has prior knowledge of basic hydrology and hydraulic principles and has reviewed the RDWYII manual. So first step here is to create a new file. We're going to save it in the chapter 13 special ditches folder. And we're going to name this Road2-SD-drainage model. And let's be sure to use the t.c2d seed file. Once the file loads, let's make sure that the default view is active in the lower left corner. And then let's attach a few reference files. We need to attach the SD alignment, SD corridor, and the SD terrain files. Let's do so by the attachment method of coincident world. Then we can fit view, and then let's make the terrain active. So before we create a utility model, let's look at the proposed profile. Let's go ahead and open up the proposed profile of the main line here. Then scroll into approximately station 147 to 165. So around this area here. So notice there's a low point on the profile around station 152 plus 00. And there's another low point around station 164 plus 00. There's also a high point around station 162 plus 50. So essentially all the flow from station 162, 50, it will collect to the low point at station 152, 50. Since there will be proposed outfall at this location. So now we can go ahead and minimize the profile for now. So likewise on the plan view, we're going to have high point here at 162.5 around this area. We'll flow all the way down to station 152. Next, we will analyze this area to see if the standard template ditch can handle this flow. So go ahead and open the Place Node tool under Drainage and Utilities, Layout and Layout. So switch to the Drainage and Utilities workflow. And then under Layout, Place Node. And then here, the warning will display asking you if you want to proceed with embedding files for drainage and utility projects in the design file. So click Yes and give the software a few seconds to load the standards from the library. Then you should get a compact database alert, and you always want to say no on those. So go ahead and open the Place Node tool once again. And here we want to set the feature definition to ditch begin 1 foot. And this will be under node and stormwater node, and then ditch nodes. And we'll leave the name prefix as it is, ditch begin 1 foot 1. We want to check this box here, elevation is the invert. We want to uncheck this elevation. Then the rotation mode as absolute. Then we can ignore this rotation angle. So now it's asking for the reference element for the elevation. So go ahead and select the terrain model. So now we want to place this node around station 162 plus 50. But here we do not want to snap to the ditch center line because the ditch location changes in the template. The nodes will lose the location and attempt to snap to a different ditch in the area of the corridor. So left click to accept the rotation mode. Then left click again to accept the rotation. And then note, for this node, the rotation angle is insignificant since it is circular. Also for this exercise, the approximate location is sufficient. So now we can repeat the last step for the ditch in node. Select the ditch in 1 foot feature definition. Then we can place this node on the north side along the roadway ditch center line at approximate station 152 plus 70. It's right at the end of this little ditch. But then, once it is placed, go ahead and press Escape on your keyboard to clear the tool. And note that the low point is around station 152 plus 00 as previously mentioned, but in this case, placing the ditch in node right at the end of the proposed ditch around station 152.70 will allow the node to utilize the terrain more accurately. Now that the begin and end ditch nodes are placed, we need to draw the ditch conduit in the software to analyze. Since the alignment is curved, a simple connection line between the points of the beginning and end node will not work. We need to first place change nodes at the vertices of the ditch center line to approximate the curve. So to determine the vertices, we will use the drawing tools to approximate the ditch center line from your corridor model. Note that this is an interpolation. The more data points or vertices you use, the better the curve approximation will be. But for this exercise, 5 vertices should be enough. So let's go ahead and open that Place Node tool once again under Drainage and Utilities, Layout and Layout. Select the Ditch Change 1 foot feature definition. And then select the proposed corridor for the elevation. Now we're going to place a node 5 different times along the proposed ditch center line at different locations. And remember to do not snap at the ditch center line. So the first one is going to be at station 155.00. So we're right around here. Next one will be 155 plus 80. And then 156 plus 60. And then up to station 160 plus 30. And lastly at station 161 plus 50. But before we place the conduit between the nodes, we need to confirm the standard ditch configuration from the proposed corridor cross-sections. So let's switch back to the OpenRoads modeling workflow. Open the Open Cross-Section View tool under OpenRoads Modeling, Corridors, Review, Dynamic Sections. And then select the proposed corridor. And then open any view to open the dynamic cross-sections. Note, you have to select the proposed corridor, not the alignment. The temporary dimension labels in the upcoming steps will not work if you select the alignment. So within this cross-section, we need to open up the Place Vertical Temporary Dimension tool under OpenRoads Modeling, Corridors, Review, and Dynamic Sections. Select the Dynamic Cross-Section View and then select the Start Point, End Point, and Dimension location For this exercise, we want to dimension the vertical height of the subgrade tie-in to the bottom of the V ditch, which should be around 1.61 feet. So in general, the ditch flow should always be below the subgrade elevation. We have a max depth of 1.6 feet in the standard ditch template. The top width is 12.8 feet with 4:1 side slopes. So then we can go ahead and close the dynamic cross-section view. So now let's switch back to the Drainage and Utilities workflow. Open the Place Conduit tool under Drainage and Utilities, Layout and Layout. And here we want to select the VDitch-User Input feature definition, which will be under Conduit, Stormwater, Ditches, and the standard VDitches. VDitch User Input. Then leave the name prefix as it is, and then leave the description as no description selected. So now go ahead and place the conduits between each node in the direction of flow, starting at station 162 plus 50 and going towards station 152 plus 70. So now open the utility properties for the first ditch conduit. So under the Drainage tab, scroll down to Physical. And notice that the rise and the span are 1 respectively. So now we need to update the values to match the standard ditch for the template. So update the rise to 1.61 feet and the span to 12.8 feet. Also notice that the Manning's end value is 0.03, corresponding to the grass surface of the ditch. If it was concrete material, the Manning's end value would be 0.13. So now let's repeat that last step for the remaining ditch conduits that were placed. And then lastly, we need to define a catchment area and the input acreage and time of concentration so that we can run the analysis. So go ahead and open the Place Catchment tool under Drainage and Utilities, Layout and Layout. And before we do this, let's turn off the Road to ST corridor. So within this Place Catchment dialog box, let's set the method as pick points and the feature definition as bare earth - steep. I'm just going to be under Drainage Area, Catchments, and then Rural. Then we'll leave the name prefix as catchment. So now left click to accept the method. And then draw a complete shape anywhere near the ditch begin node around station 162 plus 50. Then right click once the shape is complete. Note that your shape does not need to match exactly as what I draw, and it can be any closed shape within the area. A drawn area will be ignored and we will input a predetermined drainage area value. Then select the ditch begin 1'1" node as the outfall. And then select the existing terrain boundary as the reference surface. And then once the catchment area is placed, select the drainage area and notice that it shows a link to the outflow node. So now open the utility properties for the catchment. And here under the geometry section, the use scaled area, let's change that from true to false. And then now the new area here that populated, we're going to change that to 15.26. Then down under the runoff section, the area defined by, let's leave that as single area. And then the time of concentration, 0, we're going to change that to 8.53. So now that the flow is entered, let's run the model and analyze the results to make sure the ditch has enough hydraulic capacity. So let's go ahead and open the Scenario Manager under the Drainage and Utilities, Analysis, Calculations, and Scenario. So let's expand the 2-year HEC 22 Analysis Lebanon folder, and then right-click on the 25-year and select Make Current. And you should see a red check next to this scenario now. And then we can close the Scenario Manager, and then open the Compute Scenario tool under Drainage and Utilities, Analysis, Calculations, and Compute. And then let the software compute the selected scenario. And you should see the calculation summary has now been generated. So go ahead and close this window, and then you'll likely see a civil message center open on either the side or the bottom of the screen, and go ahead and close that as well. Then as a review, let's open the utility properties for one of the ditches. Then under the Drainage tab, scroll down to Results. And the second row here is surcharge. It is set to true. So this confirms that the ditch is not sufficiently sized to handle the required capacity. If you reviewed any of the other ditch segments, you should see the same result. So after reviewing the ditch segments, we know that a 1.61 foot depth and a 12.8 foot top width in the 4:1 V ditch does not adequately convey the flow between station 152 plus 70 and 160 plus 50. So this confirms that the standard ditch for the template will not suffice. And so we will need to create a special ditch in the following exercises. And this concludes exercise 13.3 standard ditch hydraulic analysis.